So let's begin with the idea of degrees of freedom. So like we discussed in one of the previous videos, that when we have a particle, that particle can move in x, y, and z directions. Now, it could be a particle combined of two or more atoms. Even then, it has the way of moving in x, y, and z direction. So, we'll say a particle can move in either x, y, and z directions like this. Right, this is uh, the standard coordinate system. So, it will have velocities like vx, vy, and vz. So when we write the kinetic energy of said particle, it would be half m vx square plus vy square plus vz square. This is what we meant by degree of freedom. That we can write the kinetic energy of the particle in three forms or in three ways, each of which uh, combines to the equal amount of energy. So for a diatomic gas, or sorry, a monatomic gas, we have three degrees of freedom. Three degrees of freedom. One, two, and three. From this, we are able to write the formulas for molar specific heat of gas and the molar specific heat of gas at constant volume. Now, what about a diatomic gas? For diatomic gas, we can say, let's say the particle can rotate like this. We can say the particles can rotate like this, or we can say the molecule rotates like this. Again, the molecules rotate like this, and when the molecule has the turn to rotate about this YZ plane, then it basically rotates like this. So that means that the molecules will only have three directions, uh, two directions in which they can have energy. So let me explain. This is the molecule which we had, right? It is oriented along z direction. So when it is rotating about z axis, it is rotating like this, right? Okay. Now it can rotate like this about y axis, and about the x axis, it can rotate like this. So about x axis, I have a rotation which has energy. Above y axis, when I'm rotating, I have energy. But when about the rotating z axis, I don't have energy. So that is the point where we have to see that a rotating diatomic molecule has two modes in which it can have energy. Plus, it will have three modes of translational energy as well. So that is the degree of freedom for a diatomic molecule. I hope that was clear. Then we have this law of equipartition of energy. So this law says that each mode of energy uh, in an atom or a molecule has equal energy associated with it, and that energy is equal to half kT. I'll write it. Is equal to half kT. So this is like a pretty astonishing law that no matter what the mode of energy is, translational or it is rotational or even vibrational, they will all carry the same energy per mode, that is half kT. So this is actually what explains uh, we have learned what we learned uh, molar specific heat. So molar specific heat uh, said that the internal energy of the gas, that is CV per mole, is equal to degree of freedom F into moles into RT by 2, right? Where did that F come from? Where does that 2 come from? So it came from our factor half K. If we multiply half kT with the degree of freedom, we'll get the total internal energy of the capacity. So that's it. Uh, Thank you for joining and have a good day.